Here's what we're hearing. Like I said, we actually have to reverse engineer our way back to more linear thinking and then elementary arithmetic where necessary, where we want to solve the problems of the universe that we already know how to solve, because if not even with notation, summa simple, we understand the foundations at least of calculus in elementary school, if not up to calculus to multivariable calculus, and we should be able to. And when you combine astrophysics, especially with to solve a problem like astrometeorology, I guess you'd call it, the chemistry on exoplanets kind of stuff, and then why it would be that way versus the way it is on Earth, or the way it is on Jupiter if it's a gas giant, because it's a star with a different amount of radiation coming from it, and the planet's closer or farther, but it still ends up being roughly the equivalent because of what the stars emit, that kind of stuff, and that's all on a curve. The orbits of the planets are on a curve. None of it is on a straight line. And with that said, that's why we're now going to look at, I said we're going to look at these textbooks that I was talking about, and we're going to look at the first one, which is actually by Professor Al Shank. I wonder if that's related to David Shank in any way, the guy that wrote The Genius in all of us. Maybe he couldn't learn calculus, and so he got to write The Genius in all of us. He talked about Ted Williams Field in this book, and what's it called? M. Night Shyamalan, Swing Away. So this is by Al Shank, with Lee Van de Vetterking and Carol Shank. Okay, so what's so beautiful about this, and so we're going to look at the table of contents. And a great way to learn, from AI is I'd like to scan this entire book in, and unfortunately OCR, I'm not sure it's really good with all of the notation symbols like I need it to be, especially if I don't scan it in particularly high quality. I just use my phone, take the picture, the way these things curve here, it screws up those things. So OCR should be able to do it, but anyway, so you can ask a question like, why does the author use this particular circuitous route through these concepts? So there's derivatives and applications 1, derivatives and applications 2, and then integrals and applications 1. And then they go into derivatives and applications 3. So why would they want to go from integral calculus back into derivatives? Is it because perhaps you need to take with you into derivatives and applications 3 knowledge that you learn, core knowledge that you learn in integrals and applications 1, and then we're going to go back into integrals and applications with integrals and applications 2. But okay, just to broaden the horizons. Wait a minute. I didn't scan in the page I wanted to. So we'll just recall it from memory, but the first page of this book in the first chapter, which is Mathematical Models, Functions, and Graphs, or actually the introduction. It was so beautifully written, and it didn't say this explicitly, but it described the difference between linear thinking and why we need to introduce calculus for curves in the most beautiful way. And it basically, like distance, rate, and time. Not enough, because there's all these, the road is not a straight line, So there you go. Why would you teach a kid to go linear first? The kid already knows that his body exists in 4-dimensional space. And you can kind of reverse engineer, and that's an important word since you're working with me, which means here's me eating my own asshole, right? But it actually, that's not the word we're going to want to learn. It's actually the ones we're going to talk about in the second book that we go over, the chapter by chapter. If we're going to look at the table of contents, this is the stuff they need to be drilling into kids' heads in elementary. This is all your elementary school child should get. But let's go back to this. So we can talk a little bit about, for historical purposes, there's something in here about Taylor's theorem somewhere. Let's see here. And why am I pulling that out? There's a lot of things. So he talks about Taylor polynomials and Taylor's theorem. I just want to briefly mention that a sacred thing happened in 2022. Another thing here in San Diego is we have Taylor's guitar. So people think calculus is learned in a quiet room with a cup of chamomile tea. No, people don't think that. That's too retarded. Where's the link to this? about how I want to be tasered and pepper sprayed. Donate to me. And this is a Honolulu policewoman that I see all the time when I'm in Honolulu. Officer Wilt, and they're making her famous. She's got a little bit of a tattoo there, but things we don't see. That we need to learn pain endurance, pain tolerance. We need to raise our pain tolerance threshold. And part of their training is they get tasered. Sometimes they get pepper sprayed. That if I had a woman to wake up next to that would get me up in the morning, not with an alarm clock, but with a nice dose of mace in the face, and a jolt of electric for cup of joe, that actually gets the body ready to heat up, punch the wall. Calculus is about motion, right? And I talked about what I saw in 2022 when I was here before my incarceration. And this is a sacred thing. So the Love Library at SDSU is a sacred place on my map in the religion of my life, because I saw these students in there. This was before summer session was going to begin. This was the week before finals. So this would have been finals week. Everybody's doing their final push for finals. And they were in there in a study room. And I saw them writing on this board. And they said Taylor's theorem. And when I saw it written, what that was, I just realized my entire life. So I talked about the way that I got my English degree was I would read books like Sutherland's How Literature Works, and I would write down every chapter title over and over and over again. If I can ingrain it into the micro muscle memory of my penmanship, I'll remember. And I do remember that book started with mimesis and ended with literary inundation, apropos. But you incorporate all of these concepts into your papers, your MLA literature analysis papers, and just A+, because it works. But what if I were writing over and over and over on a piece of paper all of these theorems, right? So that leads me to the next textbook that we're going to talk about, is this one by David Bressoud, and that one I found in the public library, Central Library, downtown San Diego, called Calculus Reordered, a history of the big ideas. But it happens to have, if you look at the table of contents, I forgot to scan the table of contents, I'm an idiot. There we go. But the first chapter, this is the preface, so and then chapter 1 is accumulation, chapter 2 is rate of change, and then it goes on and on and on. But this is the stuff they need to drill into our heads in elementary school. Just that's how you learn. Repetition is sacred. So why aren't we learning this stuff? And I talked about the reasons why in one of my videos earlier this morning. Elementary. Could have taken Kelly Simek there to another planet. But I believe we can rewind time. I have to. I have to.